Theme parks are businesses as any other. They're measured by how many people did a ride put through in 1 hour. Nothing worse than a bunch of negative publicity and social media posts. So the pressure on the maintenance crew if a ride has an issue is enormous. And the crowd is cheering once the line finally starts to move again. But how safe is that ride? Unfortunately, today's video is on a much more serious topic. A tragic accident where a 14-year-old boy fell to his death at an amusement park in Orlando, Florida, brings up questions of the safety of these rides and made me take a deeper look into the investigation's report. The odds of being seriously injured on a fixed ride in the US is 1 in 15.5 million. In other words, there are more chances of a person dying from a dog attack than being injured on an amusement park ride. Of course, these statistics are meaningless for the family and friends of the 14-year-old boy.
This report confirmed our department's findings that the operator of the Orlando drop tower made manual adjustments, resulting in it being unsafe.
Let's go through a hypothetical scenario just to show you how quickly something like that could happen. The maintenance person on the first shift adjusts the seat to allow a larger opening on the seat restraint. Before the ride can start, the safety program in the safety PLC will check every safety switch on all 30 seats to make sure they are all closed. During the second shift, the ride won't start, indicating that seat 1 is not closed. Maintenance is called, and after checking and troubleshooting, not knowing about the earlier seat adjustment, the safety sensor is slightly adjusted. The PLC program is satisfied again and the ride is ready to start.
The report confirms that manual adjustments have been made to the sensor for the seat in question that allowed the harness to restraint opening to be almost double that of the normal restraint opening range.
If you compare the two measurements, you can see that in one picture the foam of the seat is completely compressed by the clamp on the top as well as on the bottom, which comes out to about 3 inches alone of the reported double opening.
These misadjustments allow the safety lights to illuminate, improperly satisfying the ride's electronic safety mechanisms that allowed the ride to operate, even though Mr. Sampson was not properly secured in the seat.
So if we take a look at the in the report mentioned safety switches and look up the specifications, we can see that they are mounted by an M5 screw. Looking at the size of an M5 screw, we find out that it's only about 8 to 9 millimeters. The misadjustment they're referring to, as you see in these pictures from the report, is only about the size of one M5 screw head. So the difference of 8 mm on a sensor adjustment is to blame for giving the green light on an almost double restraint opening? Why then would you have a sensor bracket design with a slotted hole that allows for a sensor adjustment of almost 40 mm? If something should not be adjusted, you would typically drill it and pin it. This is usually done after commissioning and several test runs. And what about that broken seat that was not in use? Was the restraint cylinder leaking? What was the actual problem with it? Were the other seats checked to make sure they don't have the same issue? How was the ride even able to operate with a broken seat? Was the safety switch for this seat bypassed? Typically, the safety program will check that during one ride cycle the switch came on and off when opening and closing the seat restraint. This is to ensure that the switch is not permanently active. But since this seat was not in use, it had to be either deselected from the safety program or bypassed. Could seed number 1 have then also been bypassed by accident? Modern software is used these days to simulate every possible scenario in regards to material testing. Where is the weakest point? Where could the material or the weld possibly break? How can the ride be designed to withstand multiple times its maximum weight? So in the grand scheme of things, a little safety switch bracket seems unimportant, but can be the reason for catastrophic failure. This is a recent job posting for a ride maintenance technician. Responsible for daily ride inspection, repair and maintaining amusement ride equipment to ensure all ride attractions are safe and operational. And if you look at the qualifications, must be 18, high school diploma or GET, ability to operate lawnmower, leaf blower and other power tools. And that is one reason why an FMEA is so important. An FMEA is conducted with a cross-functional team with different backgrounds and knowledge. If we look at the example of that safety switch, there is too much at risk for things to go wrong when replacing a switch or worse, overhaul a complete seat restraint mechanism. A room full of design engineers may not think about the problems when replacing a switch or having to readjust it. That is why the maintenance person should be included. Also, equipment manufactured in Europe should include the maintenance person that has to work on it once it is installed in the US, not just a representation from Europe. Educational differences need to be considered in an FMEA. It looks like the switches used on the drop tower are coded, which is great to prevent override with a different actuator, because the code number on the actuator has to match that of the switch. However, that also means that the switch and actuator has to be replaced as a pair if it's broken. So when the maintenance guy with the 20 years of experience is on vacation, can the brand new maintenance guy with the leaf blower experience replace it and adjust it properly so that it is safe again, since nothing is pinned? The risk assessment is another important part. It is, for example, used to calculate the risk when the safety switch goes off during the ride. Should you stop immediately or ramp down slowly? How do you make sure that 18-year-old maintenance person doesn't forget to check important things on a complex ride? Checklists are always useful, or you could use a QR barcode in important locations. I'm not trying to discredit anybody, just wondering why only the operator is to blame for the death of the 14-year-old. Did they realize that all the rides from this manufacturer would have to get shut down if it was a design issue? Or did the lawyers calculate that the manufacturer being a European manufacturer means it would have to go to court in Europe, and that means much less money than a lawsuit in the US? And my last point, why are theme parks still managed by the Department of Agriculture? Modern rides have much more in common with the manufacturing industry. It would make a whole lot more sense, in my opinion, if they would collaborate and standardize together with the automotive industry, for example. If you found this video useful, please give me a thumbs up, and if you want to leave a comment, you can insult me all you want, just please be respectful of the family of Tyre Sampson. I posted a link to the family's GoFundMe page in the description below. And as always, thank you for watching. See you next time.